So this is we said the program consists of list of instructions, and this list of instruction consists of blocks. Each block consists of words. So this is the program list, for example, consists from instructions, and each line include one block. Each block consists from several words. Each word consists from address plus number. So the address that we are talking about is this address here. Okay. So for example, we use the word, I mean the address here with or the word which starts with O, address, for program number. So for example, you do not have only one program. Maybe you have many programs for different machines, for different operations. You are a programmer, so you need to build your own program. So usually they use the letter O to write the program number. Okay, so for example, if they said O01, this is program number 1, O02, this is program number 2, and so on. Used for program definition here. The second is the sequence that we mentioned before, and they said the sequence is represent the line number. So this is N10, N20, N30, N1, N2, N3, depends on what sequence you want to use. So this used to define the number or the line number of the block number. Then we have the G, the letter G, and we say this letter G is the main part which is used for preparatory function or preparatory words. So we have G00, G01, G02, G03, and so on. So we are going to see each number what it means. For example, G00 here is used for point-to-point rapid traverse move. So that means if I want the spindle to move from point number 1 to point number 2 at the specific at speed, so just give the command G00. Okay, and then after the command G00, I need to define the coordinate for X and Y and Z. The same for IJK are the coordinates as we mentioned, which is related to either the circle or to the arc. So if you have semicircle, you have quarter and so on. It depends on the movement, which is not line movement. It's not straight line. So in this case, we are if the movement is not straight, it's not a linear. So we are going to use the circular movement here. So we are going to use this coordinate IJK. UVW here is incremental coordinate for X, Y, Z. For X, we have U. For Y, we have V. With W, we have Z. So if you have like shifting for the X-axis, we call it U-axis. For Y-axis, we call it V-axis. For Z-axis, we call it W-axis. Then the address F used for feed rate. After F, we need to write what is the value of the feed rate. Okay, so we have a number here. This number represents the feed rate of the movement, I mean for the object to or the movement of the spindle of the machine to the directly to the object. R used to define the radius of the circle or of the semicircle or of the arc. Then S you need to use or use to define the spindle speed. H tool length offset. T tool selection. M miscellaneous commands. So M07 for example is used to turn cutting fluid on, turn cutting fluid off. M08 for example. It depends on what is the value of M. Start the end the program, end these subprograms. So M also it has its own table for different M or the most commonly used M codes. M and G here have the most commonly used coding for the G code or the CNC coding or programming. So this is the sequence of the address, and we start from N, G, X, Y. Then if we have IJK, we have here IJK. If we do not have, just we go for F, M, S, and T, and so on. So this order should be maintained through every block. So now it means since you have such F, F should become after the coordinates. If you have only two coordinates, no need to mention Z. So just go for X, Y, then go for F. If you do not have F, then you go X, Y, and M, and so on. I mean, it depends on which available commands that you have in your program or in your block of program. So this is the summary or the definition in a table. It's the same, just refer for it. The standard G and M codes, this is the most common, we said, the most common codes that used for CNC programming, which is G and M, because G here we have a very, many G numbers which used to define different tasks required by the machines. Also for the M. Others only use, for example, for specific tasks. But for example, G can be used to define multiple tasks, depends on the number which come after G. G00, G01, G02, and so on, M00, M01, M05, and so on. Okay, so usually the G code here is used or is grouped. I mean, that means there is a group of G code. So for example, some codes are more related to linear movement, some codes are for interpolation, some codes are for defining the system, the standard for measurement, some for defining the type of programming, like G90, G91 used for absolute and incremental, G28 used for reference definition, G00, G0 used for fast traverse, G01 for linear, G02, G03 for interpolation, circular interpolation, and so on. So I mean, it will be grouped, and according to their values, according to the number after G, you can understand why or what should I use this one, and when should I use G00, when should I use G01, when should I use G02, and so on. Others later, which is like FSD, is just used for one time, for example. The speed of the spindle speed is there. I mean, I just all for spindle speed. The number after F here represent a fixed, or a variable number, but it's give you the speed. The feed rate. The number of S, it gives you the speed. Whatever is the speed, is it 1 or 100 or 1,000? All the number here is represent the speed value. All the number here represent the feed rate. I mean, it's like based on equation to calculate the feed rate, equation to calculate the speed of spindle, and so on. All the number of after T, for example, is represent the type of the tool. If you have 7 tools, so tool 1, tool 2, tool 3, and so on. 5 tools, tool 1, and then tool 5, and so on. But for the G here, no, the number is give you different preparatory functions. Each number gives you different preparatory functions. So these are the main preparatory function we use for the G code. It's used for rapid moves, rapid move of the spindle. The spindle is at this point. I want the spindle to move to that point, so it will be moved to that point. I mean, how far? Very fast. No, when we say rapid move, that means it moves without performing any task in between point 1 and point 2, for example. Feed move means will move but with performing some task here. Radial feed moves depends on the circular movement. Dwells, roughing, profiling, cycle, and so on. So each one of this task or of this function, it has several or more than one G command or G code. So for example, this G00, there is G01, G02, G03, and so on. We are going to list all in sequence. So this is the table, for example, provide you with the all information of the mostly common or the most important preparatory functions. Maybe not all, maybe there is extra G code, but also not all always used. It depends on the machines, it depends on the program, it depends on the task that you want the machine to perform. For example, I may use G17, but I don't use G18, G19. I may use G02, but not G03. G03, but not G02, and so on. I can use them together in the same program. I mean, it depends on what is the requirement for your product or according to the drawing that you have. Okay, so G00 for rapid transverse. Then for G01 linear interpolation, that means from one point to other point, which is straight line. So it's not there is no circle. For 2 and 3, more for circular interpolation with clockwise or counterclockwise, either in this direction circular or in that direction circular, but either clockwise or counterclockwise. G17 for XY plane, XZ plane, YZ plane, and so on. So if you are working, depends on the 3D plane that we have in chapter 2. When we said we have like X is move left, right, and we have Y is move front and back, and Z up and down. So it depends on which plane you are going to work with. Is it XZ or YZ or XY? System of units or standard for measurement: G20, G70 here used for inch, G21, G71 used for metric units. G28 used for automatic zero return. That means the spindle will go to the 0 point or to the reference point automatically. G80 cutter compensation, cancel position, and so on. So you need, I mean, all these for here absolute. If you have absolute system, you want to use the absolute coordinate, you use G90. If you want to use the incremental coordinate, you use G91. If you want to use drilling cycle, you use G81. Zero offset, tool length, cutter compensation right, and so on. And as I told you, not all this one, the code or the preparatory comments, but this is the most important or the most commonly used with the CNC machine. For the M code here, we said M code is more on the miscellaneous functions. So it's used more on the operation of the machine, turning on, turning off for spindle here, on off, tool change. That means I want to change the tool, coolant on off, program stop at the end of the program, and so on. So it's more on the command, which is not on the, on the product itself, but this like auxiliary functions which help to complete the original code of the G code. So this is the list of the M code that we are going to use in the NC manual programming. So it's M00, for example, for program stop, M01 for operation program stop, then M02 for program end, M03 for spindle on clockwise, M04 spindle on counterclockwise, M05 spindle stop, M06 tool change, coolant on, coolant off, clamps on, clamps off, program stop, reset to start. So all these function or these commonly used M codes will be listed in the block based on the previous order or sequence that we mentioned, for example. Depends on what is the function that you want to do. For example, I want to use just one M, so you just use it for stop the program. I want to use one M to return or to reset, so I use one on. I use one M just for coolant on. Without off, it's okay, just use it for coolant on. I mean, so it depends on what is the requirement to produce the product. This is the most, the other code that we mentioned before for F, how we use F, how we use S, and how we use T. So the three here, these three also used, but as I told you, after F, there is only one type of number, which is the feed rate. So I do not have any F here. It's not like G. G, for example, I have G00, G01, G02, but this number, it doesn't mean any calculation. It's just a number, fixed number to a fixed function. But for the F here, no, it's like parameters need to be defined for the machine operation. Either depends on for the feed rate, depends on the speed of the spindle, depends on the type of the machine, of the tool, and so on. So we have the letter here as address, and after the address we have a number. This number represent or generated by using equation, and usually it is predefined to the program. So for example, I said if I want to produce this product, I need to use, for example, F equal to 25. So for the whole F, I am going to use 25. Okay. This is example how to generate or how to write the code for movement for drilling operation here. So when we said drilling operation, as we said before, we have, for example, we have 2 points. This is the first point, point 1, N001, and here we have the second point, which is N002. the command that we are going to use to make the first hole, for example, it is in the line N001. So I go to the N001 here, how to write the command to make this hole. The first is G00, which is, we said G00 is for the rapid traverse. So that means if we assume that starting point here at the 00, the spindle or the tool will go directly to this point, then go on the x-axis until reach to the value of x-axis. According to the code here, N001, G00, go to x070, y030, and then you have M03. This is how to write the code to make the hole at the, at the point, or to move that tool until the point number 1 here. Okay, so the first, move the tool. If you go back here, G000, so rapid transverse, that means the spindle will move rapidly from the start point or from the reference point until it reaches to the coordinates here for x and y and z. Okay, the value of coordinates. So as you can see here, to where from the 00 point until reach to the point x70, which is absolute coordinate in this case, for example, and y30. So this is y30 here. This is x70 at this point. This is x70, and the y30 is this point 30. Okay, so it reached to this point. I want this one to perform any task here for drilling and so on. Later on, we will see how to give the command for this one. But now we want just to draw the path for these machines or for this spindle. Let's go to this point, then, which is 30 on the y-axis and 70 on the x-axis. Then what we mean by M03 here? So if you go back here, M03, spindle on clockwise. So the spindle, when the spindle is on in clockwise, that means the spindle will rotate in this direction, clockwise. Okay, so when the spindle at this point will move on clock direction, it will make a hole on this point. After that, after I finish this block, what it will do, it will go to the next line or the next point, next line of the code or next block, and in the next block only, it will move to the second one. Where is the second coordinates here? It will move to 60. This one is 60 on the y-axis. It will be on x. But how about the x-axis? No need to move on the x-axis because it is on the same point, which is 70 here from the beginning. So the movement is not at the x-axis. And when reached to this point also, it will perform the same task, which is M03, because M03 here is not finished yet. Okay, so it will move to the second point to make the hole. This is just simple example. Later on, we will see some of the more the example which include more lines and need to be more specific to define, is it absolute, is it incremental, and so on. Later on, we will going to see such example. But here, just to show you how the spindle will move according to the coordinates here and to perform one task according to the using the M code. So this is another, also again to show the sequence for the code starting from N until reaching to the M. As you can see here in the previous one also, the previous example here, we'll start with N and then with M. In between, if we have F, we need to add F. If we have D, we need to add D. If we have IJK, we need to add IJK. But if you do not have, you just use the existing one, which is the X and Y. So here, the following information are required, as we already mentioned here. This is some information in order to write either G code or in order to write it is the same required information. Either if you want to write the G code for part programming or any NC or the in general for NC part programming that we already mentioned here. So preparatory function here, which used like the units, you are going to use inch or matrix, incremental or absolute positioning, and so on, which coordinate x, y, z, and which plane, Rx, Ry, either based on the radius, Rx or Ry and Rz, machining process, coolant on and off, and so on. All these need to be known, as we already previously mentioned, when we write the G code. This is how this is example for G code program. So usually the G code program that you are required to learn how to write is like this one. Okay, it consists from sequence of numbers or lines or blocks. Each block consists of words. Each word consists from address and numbers. So for example, line 1 here we have G90, G20. So G90, for example, for absolute coordinate, G20 is for metric measurements. So need to define, for example, the type of measurement, either inch or millimeter. You need to define, is it absolute or incremental, because these are main parts. Then you need to go for what type of the aim, which miscellaneous functions that you are going to use, what type you are going to use, the T3, T1, T2. Then you go, for example, to define what is the speed rate, the spindle speed, what is the feed rate, what are the coordinates, and so on. So this is, the typical or the form of the G code in C program, which actually, if you go through this one, you are going to find two main parts. It's the first, which is related to the G code. So you can find all the preparatory function like G here, G there, G this one, here, all G, G, G. And if there is no G, you are going to find M. So you can find M in this line, M in this line, M at the end here to stop the program, and so on. The rest will be the other address, like the coordinate for X, the coordinate for Y, because if you have, if you run already one of these code like G01, so G01 here will be applied for this line and also for the next line, because there is two types of the G code. One, we call it the modal, and one is non-modal. We are going to see later on. So for the modal code here, the code here, if you said for the machine to make drill, to make a hole drilling, so this drilling will be applicable for this point and for the next destination point. If you said the machine need to move from this point to the next point, so the movement will be from the first position, also will be applicable for the second position, for the third position, until you have another G. So here you have G01, for example. This G01 will be applicable for these coordinates, and also will be applicable for this line. Not only for the line here, but after finish this line, it will move to the other line. This is the idea of modal code and modal, G modal and non-modal. We are going to see later on. Okay, so that, but this is how the program. If later on I ask, for example, to write a program, I don't want you to write like program in C or C++, or you write a program in MATLAB. No, it's not about such type of program. The program that we mean in NC course is on CNC machining program. So it looks like this one. Is it clear?
Yes.
Okay. So this that type of modal and non-modal code, and we said the modal and non-modal is we mean by modal and non-modal is if the code or the impact or the effect of this code will be extended until where? Is it only G01 applicable for this line, or this G01 will be for this line, the second line, the third line? How we know this one? So the modal code here, the modal G mode, or the modal G code here remain active until the another G code from the same group is programmed into the block. Okay, so here I have one G code applicable for this block, applicable for the second block, applicable for the third block, until I have another G code from the same group. So for example, you are going to see later on in the table, there is some group under, some G code under group 1, some G code under group 2, some G code under group 3, and so on. So it depends on in which group is the G code. So also you are going to see which one is modal, which one is non-modal. So the modal one here, if I have G01 here, is still effective in this range. So all these lines will be affected by G01 action. What is G01? If you go back, G01 is linear interpolation. That means if I said linear interpolation, that means for the first 2 points, it will make a line, move a straight line. Then there is another 2 points, for example, go down, straight line, then go back, straight line, go back, straight line, and whatever is the number of coordinates that I'm going to define for this G01 function. Then until I enter another G code. So from the same group. So this is G01, this is G00, G01 and G00 are from the same group. So if I have here another G00, it will replace the G01. So now all the tasks will be conducted after this G00 will be, will apply the G00 code, not the G01 anymore. So the effect of G01 stop here, then start G00. Like we see in the drilling example here, we said this is mean the spindle will rotate counterclockwise. I mean clockwise. So the impact of M03 here will also applicable for the second one, not only for the first coordinate, not only for this point. No. So when move to the second point, it will take the impact of this M03 until we remove or we stop. We give another command to return to the reference point, for example, or to stop the machine or to stop the program. The non-modal function here is just only one short code. One short code means it's just applicable for one line. So a non-modal G code here must be programmed into block when it is required. Only when I need it, I use. It's only effective in the block which is specified. So its effect will not move to the second line, to the second block. It only affected in its place. For example, here G09 is exact stop check. So this will be applicable only on the block of program which is included, not affect any for any extra other coding. So this is the table for modal and non-modal G codes. So as you can see here, there is G00, G01, G02, all located in the same group, which is group 1. Then we have G04 is group 0, G28 is group 0, and this all you can see non-modal, non-modal, non-modal. So you can see here the type, is it modal or non-modal, and for what it will be used. Depends on. All the 0 here are non-modals, the 1, the 2 are modals, and from the same groups. So this just extra slide to explain which group and which G code is related to which group. For example, for group 1, we have G00, G01, and all these G are belongs to group 1. Then here all G17, 18, 19 belong to group 2. Here group 3, 90 and 91 group 3. Group 5 is 93, 94. Group 6 is G20, G21, and so on. So it's more on the type of or the model groups for the G code here.